Hi everyone. So today we're going to solve the code problem with 49 group anagrams. So anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So let's suppose we have two strings S and T. Okay. If you can create T using all the characters of S, then we can say that S is an anagram for T, or vice versa in this case, because it's already written using all the original letters exactly once. Okay, so in this problem we have to group all the anagrams possible in the given array. For example, over here we have eat, tea, and eat. We can create any of these by using any one string or any of these strings, right? So these can be clubbed together. Similarly, other examples as well. Okay. So to tackle this problem, we mainly have two solutions, two way to approach this. First one is using sorting of the strings, like individual strings, and hashing it. And the second solution includes creating a 26 bit array. Each bit will represent characters in A to Z. For example, not an example, but it's a constraint that we will only be getting all the lowercase English letters, right? So basically, there are 26 English letters, and we can create a 26 character array, 26 bit array initialized with 0. And we will simply just keep on adding one uh, at the index of each each character. For example, A. A is the first element, so we will add one to whatever number. For example, initially we are starting with 0, but in the later phases, whatever number is there at the first index, we will add one. And all the strings which will produce the same 26 character array will be grouped together. So let's see the code and I'll explain on the go, if there will be any complexity or anything else which can be tackled. Yeah, so as mentioned, I'll be writing down the code for both solutions. First one is using sorting and hashing. So the result dictionary which we'll be creating will look something like this. Okay, where we will have a sorted string, and we will create a list of all the strings which will cause the key when they are sorted. And second one will be like 26 bit array. Each bit will represent a single character, and we will group all the letters which can produce the same 26 bit array. Okay, so let's start with the first solution. Uh, I'll be using the same dictionary when for both the solutions. Let's say, let's start with the solution one. In this, like it's a very straightforward solution. So what I'll be doing is, let's say, I'll be just iterating through the given array, and I will be sorting each string. Okay. So what I'm doing is basically you cannot create key with a list. Like list is mutable in nature, and by the by the definition of dictionaries, you cannot have a mutable thing as a key, mutable data as a key for dictionary. Okay, so what I'm doing is I'm just simply sorting uh, the given string, and I'm just creating this here a string out of that. Okay, we are done over here. We will, sorry, add this as a key, like we will be updating the key of this sorted. For example, let's say a string produced AET. Okay, so I'll be updating that key if already existed. Otherwise, I'll add the value into it. Okay, and so with this line, what I'm doing is I'm checking if this key is already over there or not. If not, I'll initialize it with a blank list and I'll add the element into it. Okay. And at last, you just have to simply return all the values. So let's see if the test cases gets passed. Yeah, so we were able to successfully pass all the test cases. Let's submit for further evaluation. And the solution got accepted and we performed exceptionally well. Like we outperformed 99.68% of the solutions with this approach. So let's try out the other approach as well. I'm going to comment out this one for now. So in this approach, I'll be using the same dictionary which we created, and I will iterate through the given array. And for each string, I will be creating an array of length 26, all initialized with 0. And now what I have to do is I'll have to just simply iterate through each character in the given string. Okay, so for each char in value. Okay, so now what you can do is to get the exact index of that element. What I'll be doing is I'll be using the ASCII codes for each character. Okay, so count of odd and each character. But the problem is the ASCII code for, let's say, E in any case would be something like 89 or something, right? But we have the array initialized like starting with 0 index. So to get that, what we can do is we can just simply subtract out the ASCII of A. Okay. So for, let's say, for example, for E we received 89. Okay. And ASCII code for small lowercase a is 80. Let's say I'm just assuming some number 83. So the index will be 86 in that case. Okay. So this will solve the issue. And I want to. So now, as of now, we have a array in the count, but we cannot use list or array as a key. So I'll be typecasting that into a tuple, and I'll be updating the result of the existing key if it is there. Exact same concept which we have used above. We have to use value, yeah. And at the last, I'll be returning result dot values. Looks fine. Let's see. Hmm. Built-in method values of ticked object it is not valid. Value for expected return. Oh, sorry. I forgot the parenthesis. Yeah. So the test cases got passed. Let's submit for further evaluation. Yeah. So the solution got accepted, but we received we surpassed 80% of the solution, which was less than the solution number one, which we tried. Okay. So thanks again, guys, for watching the video. And one more thing, like this video will be a part of a playlist called Array and Hash on our channel. So thanks a ton. See you again.